Every maintenance planner knows this frustration. You're creating a work order. You know the equipment. You know what's wrong. But your system doesn't know what you know. It can't see the operating conditions. It can't see the sensor trends. And it definitely can't help you classify the failure correctly. What if it could? This is Opsworth work orders. It works with your existing CMMS, not instead of it. Its job is simple: to bring evidence and consistency into how work orders are classified. We connect maintenance data, asset context, and sensor history, then apply structured, rules-based logic so similar work orders are classified the same way every time. Each classification is added to a growing knowledge model, so your maintenance history becomes more consistent and more useful over time. The result is cleaner maintenance data, clearer insight across Opsworth analytics, and faster, more confident decisions for planners and reliability teams. Notice we're logged in as a maintenance planner in Greenfield mode. Greenfield is for organizations just starting their classification journey. The system provides extra guidance and coaching. As your data matures, thousands of classified work orders later, Opsworth adapts automatically, showing more insights. Now, let's create a work order for P101A, a critical feed water pump. Immediately, Opsworth pulls together everything you need: equipment class and location from your asset registry, MTBF, or mean time between failures, calculated from your actual failure history, and something most CMMS systems don't show you: operating context. This pump is classified as critical to your process. It runs continuously, 24/7, no breaks, and it operates in severe conditions: high temperature, corrosive environment. Why does this matter? Your standard PM interval might be 180 days, but this pump, with these operating conditions, Opsworth calculates an adjusted interval of just 92 days. That's not a guess, that's math. Criticality times duty cycle times service condition. 0.75 times 0.85 times 0.80 equals 0.51. Half the normal interval, because this equipment works twice as hard. And here's the key: this calculation is auditable. When someone asks, why do we PM this pump every 90 days, you have the answer. But operating context is just the beginning. Opsworth integrates directly with your sensor systems: vibration, bearing temperature, seal temperature, discharge pressure, motor current, flow rate. 6 parameters, live from your plant. See that bearing temperature trend? It's elevated. The seal temp is climbing too. This isn't just data in a historian somewhere. It's evidence, right here, right now, connected to this work order. When your technician arrives at this pump, they'll know exactly what the sensors were showing when the work order was created. Now, let's describe the problem. Pump leaking from mechanical seal. High vibration observed. Bearing running hot. Watch what happens. As you type, the Amphograph knowledge graph is analyzing your description. It's detecting terms leaking, mechanical seal, vibration, bearing, and matching them against your organization's ISO 14224 vocabulary. This isn't AI guessing. This is deterministic, rule-based classification. Same words in, same classification out, every single time. Problem: overheating, 70% confidence, matched from leaking. Failure mechanism: bearing wear, 46% confidence, matched from mechanical seal. Now, you might notice the system suggested overheating when we said leaking. That's because it found a vocabulary match. You can see exactly why. Accept it or change it to leak if that's more accurate. The point is, you're in control, with full transparency into every suggestion. The quality score shows 65, fair. Not bad, but look at the issues panel. No timing information and no measurements provided. The system is coaching us, telling us exactly how to make this better. Let's follow its advice. Started noticing this since yesterday. Vibration reading 2.8 millimeters per second. Bearing temperature 52 degrees Celsius. We added timing, since yesterday. We added measurements, 2.8 millimeters per second, and 52 degrees Celsius. Now look at the quality score. It jumps to 100. Excellent. And notice, those measurements match the live sensor data at the top. That's not a coincidence. That's evidence-based maintenance. Opsworth also knows this equipment's components and failure history. 7 components on this pump: coupling, bearings, impeller, mechanical seal. The system understands the equipment hierarchy. And look at the recent failures. 190 days ago, leak caused by seal failure. 372 days ago, high vibration caused by bearing wear. Sound familiar? This isn't just convenient, it's pattern recognition. When you see the same failure modes repeating, that's intelligence you can act on. Now you have everything: operating context, live sensor data, intelligent classification, component hierarchy, failure history. One click accepts the high-confidence classifications. One click creates the work order. And that work order carries all of this context with it, not buried in a notes field, structured, searchable, auditable. Here's what just happened and why it matters for your plant. Knowledge protection. When your experienced planner retires next year, their expertise doesn't walk out the door. Every classification decision they made is captured in the knowledge graph. Searchable, reusable, permanent. Pattern detection. This seal failure joins P101A's history. When the same pattern appears on P102B next month, Amphograph connects the dots. Fleet-wide failure patterns become visible, not buried in text. Maintenance optimization. With structured failure data, you can finally answer, why do our pumps fail? Not with opinions, with evidence. Adjust PM intervals, target root causes, reduce downtime. Regulatory compliance. Every classification links to source evidence. When auditors ask, why was this coded as seal failure? You have the exact text, the matched vocabulary, the decision trail. Your CMMS gets structured data it can actually analyze. Your reliability engineers get patterns they can act on. Your knowledge stays in the organization forever. And you? You just saved 10 minutes of manual classification, and you know it's defensible. But here's where it gets really powerful. All those work orders, with their structured classifications, feed into predictive analytics. Equipment risk heat map. P301A and P202B are showing elevated risk. Remaining useful life. P301A has 42 days before likely failure. What if analysis? If I defer maintenance 30 days, what's my risk? This isn't a separate system. It's the same knowledge graph, just viewed through an analytics lens. Taxonomy graph. Your ISO 1422 for vocabulary. Facility graph. Your equipment hierarchy. Evidence graph. Every classification linked to source text. Inference graph. Every decision with proof traces. This is your maintenance knowledge, structured, connected, queryable. Opsworth doesn't replace your maintenance system. It turns every work order into organizational intelligence. Evidence-based classification. Operating context that matters. Predictive insights that protect your assets. Opsworth maintenance. Your knowledge, structured forever.